Hi everybody, I wanted to talk about the normal distribution and how to work with it to find probabilities and to find the data point at which a probability occurs. So the normal distribution, you'll have to forgive the drawing that I'm about to do because I am doing it with a mouse, but it's a bell-shaped curve. It should be symmetric. Okay. You want to emphasize the fact that these tails never touch. So an incorrect drawing of the normal distribution might look something like this, where these definitely end right here and right here. The actual normal distribution goes on forever in both directions. The probabilities just get much smaller as we move out, but they don't stop existing, which is an important difference between the two drawings. The standard normal probability distribution, difficult to do, that's a crazy D, has a mean of 0 and a standard deviation of exactly 1. What that gives us is a special relationship between the numbers on the x-axis and the z-scores. So a z-score is usually how far you are from the mean in terms of standard deviation. But when the standard deviation is exactly 1, that means that our ticks on the number line are exactly the same as the standard deviations for the number line. So for the standard normal distribution, whatever number I am at on the number line is exactly the same as the z-score for that number line. This number 1 is one number up from 0 and also exactly one standard deviation away from the mean. So its z-score and its placement on the number line are exactly the same. So for 3, the z-score is 3 and the placement on the number line is also 3. For -2, the z-score is -2 and the placement on the number line is also -2. So the standard normal distribution is exactly one distribution, and it's this specific distribution and no other distribution. But we can have a non-standard normal distribution. And that's what we usually have in reality around us, is that we have a bell-shaped curve. Let's try that again. Okay, and that bell-shaped curve doesn't usually look so perfect or have these perfect standard deviations or even have a mean that's 0. So this mean might be at like 68. And it might have a standard deviation of, say, 2. And so I would go 70 up, and then 72, and then 74, and I could go down to 66, and to 64, and to 62. Okay, so now I've drawn a complete normal distribution. So on the exams, when I ask you to draw a complete curve, what it's asking for is a drawing of a curve with a mean and 3 standard deviations above and 3 standard deviations below the mean. So we can use these to make a relationship between data and to find either areas inside the curve, which are the same as probabilities, or the data numbers on the bottom of the curve based on a probability. So there's really two types of questions we might see here. We might see the type of problem that has an area inside the curve marked out. So it might look something like this. And it might say, find the data point that corresponds to this, say, 70% of the graph. In this case, they would tell us a mean. They might say the mean is 20, and they might give us the standard deviation, and they might say the standard deviation is, say, 1.4. And then our job is to try and figure out what this number is right here. What makes this yellow area start and stop? We have multiple ways to do that, and the homework will walk you through using a table. I would suggest using Excel because, 1, it can give you more digits than the table, and 2, it can be more intuitive to use than the table and take a lot less time and resources. So let's look at this. I'm trying to find a number given an area. So what I'm going to do is go over here and use equals norm dot dist. And you can see there's more than one. There's norm dot dist and there's norm dot s dot dist. The S stands for standard. So if I'm using a standard normal distribution, I would use this one. Since I'm not, and I know I'm not because my mean is 20 and my standard deviation is 1.4, Remember, for the standard normal distribution, it would be 0 and 1. I would use a regular normal distribution. This is going to ask me for some inputs. It's asking me for an x and a mean and a standard deviation and whether or not it's cumulative. So starting right at the beginning, I can see I don't have an x. These are the x values down here. I don't know the x value. So I can't use this. Let's try the other one. Okay, so this other one that pops up is the inverse, and if I see here, it asks me for a probability and a mean and a standard deviation. So just from reading the inputs it's requesting, I can tell which one I'm supposed to use. Another easier way to remember would be that when you're given information on the inside of the picture, you use the inverse graph. This stands for inverse. So inside goes to inverse, makes it a little bit easier to remember. But if you can't remember and you're stuck between distribution and inverse, you can always read through the inputs and see whether or not you have them. If I don't have them, this can't be the right distribution to use or Excel command to use. Okay, so this one's asking for probability, which I'm going to put as 0.7, and the mean, which I'm going to put in as 20, and the standard deviation, which I'm going to put in as 1.4. And it's giving me back this value of 20.73. So 20.73. All right, so to go from an area to a value on the X table, what I do is I draw a picture so that I have a good idea of what I'm looking for in the picture. I note the area that I'm given, I note the mean and standard deviation, and then I use the inverse to find the number that belongs down here. The inverse function and the tables in the book both use the left-hand side of the distribution. So in other words, if I'm looking up areas in the table in the book, they're all the area to the left of the number. If I'm using the normal inverse operation, it's giving me the area to the left of that number as well, or I'm inputting the area to the left of that number. So that means that we have to think outside the box when we're looking for areas to the right or in between. And we'll deal with those in a minute, but I did want to look at the other method for these problems. So this first one is the method where I was given an area and I found a number. So what if instead I was given a number? So let's say the mean is 20 again. And I'll go ahead and say the standard deviation is once again 1.4. And now the problem is asking, let's see, how much area is to the left of, say, 18? So now the problem is not asking what number belongs to the area, but what area belongs to the number. So now I have to try and find this area right here. And that's where my question mark belongs. I don't know what this is. So if I go back over here and I try that norm.dist, I can see that's asking for an x value, which I'll tell it is 18, a mean, and a standard deviation. And then the last question it asks is cumulative, and we've had a long discussion on this, what cumulative means and which problems it applies to, and the good news is, once we move on to our continuous distributions, for our class, not in general, but for our class, we will always be a cumulative. So it is always just true, or alternatively just 1 at the end. Okay, so it's telling me that the percentage that belongs here is about 0.8%. Oh, sorry, decimal, so 8%. Okay, so these are the two layouts I can have. I can go from an area to a number, or I can go from a number to an area. I've designed both of them to work with the left because that's the simplest case, but we can use our worksheet to deal with some more complicated cases that aren't always on the left. Okay, so this is our worksheet, and we're going to go through this first problem that deals with the normal probability distribution. So this one is GPAs of Sunny Oswego freshman biology majors have approximately the normal distribution. So I'll go ahead and highlight that part because on the exam I'm trying to figure out what kind of problem I'm doing. Okay, and it also told me the mean is 2.87 and the standard deviation is 0.34. So I'm going to highlight them and I'm going to write them down because I need them. So the mean is 2.87 and the standard deviation is 0.34. Ooh. Okay, so now it asks, in what range do the middle 90 of all freshman biology majors lie? So, in other words, what GPA cutoffs tell us the middle 90% of the freshman in biology. So what I can do is start with my drawing, because the drawing is going to help a lot with figuring out what parts go where. I'm trying to draw a picture of the middle 90%. So I know that I have a bell curve. I know that in the middle I have 2.87. And the standard deviation is 0.34. Okay, so now it's asking me for the middle 90%. So I don't know where the numbers are, but I know the middle 90% is going to be in the middle of the graph. I know that percentages are associated with the inside of the graph, just like a histogram, which has many bars that represent percentages. These bars are so tiny that I can't see them really, and I'm just viewing the graph that they make when I draw a line over the top of them. Okay, so then I know this middle part is supposed to be 90%, the shaded area. And I'll write it as a decimal because I have to do math with it anyway. So I've got a middle 90%. If that's in the middle, then what I have on each tail has to be a 0.5%, 0.05. And I want you, if you don't know why this is true, to go ahead and pause the video for a second before I explain it and maybe stare at the picture and see if you can explain to yourself why these two areas are 0.05 before I start explaining it right now. So hopefully you had a chance to look at it. If the whole area under the curve has to add up to 1, which we know is true because this is a probability distribution and that's one of the rules, that the area adds up to 1, and 0.9 of it is in the middle, and we already know it's in the middle and that the curve is symmetric, then the leftover 0.10 would have to be split up into each side. So you can think of it as I have 90 cents in the middle, so that gives me a dime left over. So I have a nickel on either side because I have to split it symmetrically. So keeping in mind that Excel can only deal with the left-hand side or the left-hand area, I have to find both of these numbers, but I have to do it with an input of an area on the left. So if I look at this question mark, then I can see the area to the left of this question mark is 0.05. So in Excel, I would do norm, and then since I have areas inside the curve, I'm going to use the inverse function. The probability of 0.05. The mean of 2.87, and the standard deviation of 0.34. And that gives me 2.31. So I'll go ahead and write it down. 2.31. Okay, so now I need to do the same thing, but I need to do it for this question mark. This one's a little bit more complicated because I have more area to the left. So how do I figure out the area to the left for this question mark? And that would be, well, let's see. I have 90 here, and I have 0.05 here. So the area to the left of this question mark must be 95. And a quick way to check is to make sure that it still adds up to 1. So if I say 95 is over here, then this has to be 0.05 to make sure it still adds up to 1. And that's true, so let's go over here and do that math. And again, I can use the copy-paste feature in Excel. So copy and paste, and then I just have to edit this 0.05 to be a 9. And I've done the same math, and I've got 3.42. Let's see, 3.42. So this one is a little bit harder to see because of the symmetry and because of the strange or the more difficult to interpret standard deviation, but these should be the same distance. So in other words, 2.87 minus 2.31 with an equal sign in front so it knows I'm doing math should essentially be the same as the difference between this and this. So I can do it either way. If I subtract that from that, I'll get a negative, and if I subtract that from that, I'll get a positive. Let's do it the same way. So equals 0.87 minus 3.42, 2.87. Try that again. 2.87. And so with some rounding error, these are essentially the same distance from each other. Oh, in fact, if I had rounded this correctly, I probably would be in better shape. So this is 3.42 9. So this should have been 3.423. And I'm sure if I make that edit, then I will get the same number like I was supposed to. 4, 3. There we go. Now we have the exact same number. So these, because the graph is symmetric, these are symmetrically distanced from each other. The difference between the mean and each number should also be symmetric. So you have lots of ways to confirm that you're doing the calculations correctly. Okay, so let's try one that goes in the other direction. So in other words, a problem that gives me a number and I have to find an area. So what we'll do is part 3. I'm going to go ahead and change my highlight color because I'm highlighting for a different problem. So what proportion of freshman biology majors have a GPA above 3.5? So now they're giving me a value and they want me to find the proportion or the probability. So let's go ahead and we'll switch colors as well since we're doing a different problem. And we'll go look at the math for that. So just like before, the first thing I want to do is draw a picture because that will help me figure out what I know and what I'm looking for. So I'll move over and I'll draw a picture right here. I have the same mean and the same probability because it's part C of the problem. So this is still 2.87. But now what they're looking for is how much area is above the number 3.5. So I don't know exactly where this number lies because I haven't put in all of my standard deviations, but I know it's above 2.37, and I know it's significantly above it because my standard deviation's, pretty small. So I'm at least 1 standard deviation above. No, more than 1. It looks like I'm 3-ish standard deviations above. So the area I'm looking for is right here on the picture. I'm trying to find this area. So since I'm given a number on the outside and I'm looking for the area on the inside in Excel, what I'm going to do is norm.dist. I'm going to give it 3.5 and a mean of 2.87 and a standard deviation of 0.34. And as always, it is cumulative. So true or 1. And then I can look at that, and that says 97% roughly, right? So I just did the math and I got essentially 97%. Before I type this into my math lab or circle a multiple choice question or write down my answer, let's make sure that seems reasonable. There is no way this little tiny area right here on this big graph is 97% of the graph, right? 97% of the graph has to be the majority of the graph, and I've highlighted the opposite of that. I've highlighted a tiny part of the graph. But remember, Excel can only give me back or intake the left-hand side of the area. So what it's given me back is not the area I wanted. What it's given me back is right here. This is 97% of the graph. Right? So if this is 97, then this must be roughly 3. And obviously, I want to be more accurate with that answer, but for now, I'll just take roughly 3. To be able to find the exact answer, what I would do is equals 1 minus this number right here and enter. And I can see I get roughly 3 back. So the area to the right of this number is roughly 3%. And so, answering their question, the proportion of biology majors that have a GPA above 3.5 is roughly 3% of the biology majors. So I hope you found this helpful when you're going through these worksheets. Remember, the most important step in solving any of these problems is to draw the picture so that we can identify what parts of the information we're given and what parts of the information we're looking for. So that's a really hard part to understand from just reading the problem.